I'm here to give a strategic update of Xilinx. We've been going through a corporate transformation for about 4 years, and we just this year hit a major milestone in transforming the portfolio, which supports the transformation of the company. Let me just start with a quick overview of Xilinx. For those of you who follow us, you know we've done about $2.4 billion in the last fiscal year. We've had a history of innovation with over 60 industry firsts, about 10 of those being in the last 4 years that really enable us to pursue this corporate transformation. We now also achieved market share that is beyond 55%, and I want to touch on that just a little bit more. If you break it out, our market share total has moved from fiscal year 11 at about 53% to fiscal year 15, which hit about 56%. In the high end, we stayed even. We continued to have a leading share of about 60%, whereas in the mid-range, we went from a very low 1% up to 54%, and the low end actually grew share almost 10 points from a base of 40 to 51%. When you look at the leading edge nodes at 28 nanometer, we ended up with 62% overall segment share, and at 20 nanometer, over 70%. Now I'd like to go into a little bit more about this corporate transformation. We've talked about transforming ourselves from a programmable logic company to what we call an all programmable company. That includes all programmable technologies, hardware programmable, software programmable, and I/O programmable. Those technologies are mixed into a portfolio of all programmable devices. Those include FPGAs, all programmable system on chips, and 3D ICs. We now also support the programming of these devices with all programming models. So that's traditional hardware-centric programming models, which is RTL-based, as well as what we call software-defined programming models, which are based on C, C++, and overall higher levels of abstractions and languages. All of these together enable us to pursue all programmable electronic systems and networks, which is really the top-level megatrend in our industry. So what we've done is we've set an aggressive course for the next 5 years. If you look at this chart, it's really like a timeline. Prior to 2011, we were a programmable logic company focused on FPGAs and traditional ways of programming those FPGAs. We then, in 2011, introduced our 28 nanometer portfolio. This included technologies that were beyond hardware programmable to software programmable, especially embodied in our Zynq SoCs. We also expanded our design environments to higher levels of abstraction using C and C++. Now in 2015, we've introduced a number of new elements to our portfolio. Multiple, what we call SDX, software-defined development environments to go after the broader set of users, systems, and software engineers. We've introduced MP SoCs, which are multi-processing system on chips with 7 software programmable cores. This allows a much higher level of intelligence and integration. So we've now expanded ourselves from just all programmable to also all programmable and software-defined. And that allows us to pursue not only the 50, maybe 70,000 hardware engineers, but go well beyond that, potentially to 5x that, 250,000 or more systems and software engineers, and also align ourselves to the highest growth industry megatrends. What we're doing is removing many of the barriers to much broader adoption of our technologies and deployment into these new generations of smarter and connected systems. So first, we're changing the programming model. We're now moving to software-defined programming models, complementing still the RTL-based programming models of the past. We've also moved to higher levels of intelligence and integration in the silicon products that we offer. And those two things together are enabling us to participate in many of the highest growth industry megatrends. Those include video and turning that video into some kind of intelligent vision, or machines that see, interpret, and then act on what they see. A major application of vision-based systems is ADAS, and also the road to autonomous vehicles. When you think about the future of those vehicles, they'll also be connected, and they're also part of what we call the industrial Internet of Things. That also includes smart factories, smart energy, smart cities, and a host of other connected machines and systems that ultimately change not only core systems and technologies, but also entire societies and the way we operate. Much of this will also be enabled by the next generation of wireless technology. We all know that 4G changed the way that we experience our smartphones, and 5G will do that as well, but there's many other new elements that are really targeted to enabling the next generation of these connected machines and connected societies. These infrastructures will also change in terms of how we communicate. We're going to have more software-defined networks and virtualization of many of these network functions that are encapsulated in these terms of SDN and NFV. And of course, a key element of NFV is to leverage the cloud, but of course, many other elements of everything we do every day will also be done in the cloud. And that leads us to the final element, or the megatrend of next generation cloud computing. So if we go up to even a higher level, what we're solving is something we call a programmable dichotomy. There are things pulling us towards software, but also an equal number of things pulling us towards hardware, but yet all with the need to retain the flexibility through programmability. So there's a number of things: flexibility, intelligence, scalability, centralized control, ease of development and ease of upgrade that pull you towards software. But there's also a number of things: big data, video, multi-level security, the need for instant response with low latency, low power, and also any-to-any connectivity that really pull you towards the need to optimize in hardware. So Xilinx is addressing this programmable dichotomy by combining elements of software-defined programming models with hardware optimization, using our new SDX software development environments, with the core of that being based on high-level synthesis, leveraging high-level languages, and also hardware optimization based on FPGAs and all programmable SoCs and MPSoCs. This is enabling all programmable systems and all programmable networks. So we're doing this through a new era of offerings. It's really our new portfolio. And I could not have talked about this in 2014. But as of 2015, we've now introduced 3 new software-defined development environments that we call SDX. We also have introduced this new generation of SoCs we call MPSoCs, multi-processing system on chips, with a new generation of intelligence and integration. And finally, we're building on another generation of ultra-scale ASIC-class FPGAs and 3D ICs. So when you look at what we're doing, is we're really creating software-defined leadership to complement what we've done traditionally with RTL-based design. Here's a map that shows the different alternatives our customers have. On the vertical axis is ease of development. On the horizontal axis is performance per watt and any-to-any connectivity. If you look at the CPUs and GPUs and NPUs and other alternatives like the software programmable SoCs, they've traditionally been much better than we have been at ease of development. But they've lacked the kind of performance and power and connectivity that we've offered. What we're doing now is moving up to try to match the ease of development of these other alternatives while retaining all of the advantages of the performance, power, and what we call any-to-any connectivity, critical for the next generation of connected devices and machines. So with this leadership, we're able to define our company in a much broader way. When we say all programmable, we're talking about all programmable technologies, all programmable devices, all programming models. It allows us to provide a combination of software intelligence with hardware optimization and any-to-any connectivity. That's any media over any network, using any standard, talking to any machine, talking to any other machine. And we have a much broader portfolio of FPGAs, SoCs, MPSoCs, 3D-ICs, ASIC class hardware tools, and now also these software-defined development environments. When you look at the alternatives I showed you in the previous graph, you can see that they lack many of the things that we provide. They do not provide the any-to-any connectivity. They cannot provide customized hardware optimization. They don't allow our customers to truly differentiate, and they're not all programmable. So these all programmable solutions enable us to participate now in these high growth megatrends. And I'll now touch a bit on the requirements of those megatrends. If you talk to a CTO, for example, in our customer base, they will talk about this list of requirements. They want their next generation technologies to be connected. Because they're connected, they need to be secure. Often they need to be safe. As we talked about, they typically need to be software defined. Many of the functions need to be virtualized, whether it's in a cloud or it's in an embedded system. A lot of intelligence comes through analytics. Often these are machines that see or have to deal with video. And they have to be enabled with scalable multi-processing technology that also supports high degrees of acceleration and hardware optimization. So all of these megatrends require these next generation requirements. With the new portfolio that I described earlier, we now can support each of these next generation requirements. Let me contrast the old Xilinx with the new Xilinx. Programmable logic versus all programmable. So programmable logic had enabled our customers to do connectivity, typically focused at the chip level and maybe to the backplane, but not necessarily a broader view of the new connected world of machines talking to other machines. They also supported acceleration, functions that maybe needed some special performance or lower power. When you look at all programmable technologies and this list of next generation requirements, you can see it's much, much broader. All of these elements now are supported with Xilinx's all programmable portfolio, whereas in the past, as you see, only a small subset were supported with the traditional programmable logic portfolio. So this has allowed us to really complete our corporate transformation. We can now say we've moved from the left side of this chart to the right side, from programmable logic to all programmable, from supporting glue and bridging applications and acceleration to now enabling smarter and connected systems. From design environments that were focused on time to implementation to design environments with higher levels of abstractions that enable the fastest time for differentiated systems and networks. We're moved from supporting only FPGA engineers to systems and software engineers, and from a focus on IC features to really system value. So as I said earlier, we've set an aggressive course for the next 5 years. In 2011, we moved from programmable logic to all programmable. And now I can say in 2015, we've moved to software-defined and all programmable, aligned to the industry's highest growth megatrends. And as part of that, we're expanding our user base approximately 5x in the next 5 years. Thank you.